statistics associated with the measurements of neutrinos, just a few per year sort of thing. They are particles that can make an event, a burst of light or whatever in your detector. Dark energy is inferred by measuring how the velocity of supernova, where they know how much light is being put out, versus, and they measure the velocity by Doppler shift compared to the distance that they are away. They measure velocity versus distance, and they discover that there is a discrepancy. They must have been accelerating somewhat and decelerating somewhat. And the effect of the acceleration is what comes from dark energy, and deceleration comes from the rest of gravity.
So neutrinos are not associated with this?
They aren't really associated.
They're not.
A few per year sort of thing. There was a lot of speculation about whether there was any relationship, but superchemical Kennedy has done it best, and they have seen no significant things. About 3 minutes altogether. It's amazing. John is going like this, but it's amazingly smooth compared to elevators. It's not too bad, actually. And you get down to the bottom, and in the meantime, you're listening to the miners, you learn 2 or 3 new words. And you get off at the 6,800 foot level. They still use engineering units. You have to walk about a mile to the detector. Take a shower, change your clothes, put on a hairnet and a safety hat, and then you walk out into what you can see is a very clean area underground. And the whole area, this is now the new SNOLAB, which it's been expanded to, is a very nice way, very nice place to work. You really don't notice. You get asked that all the time. You notice there are no windows and that you're not underground. It turns out you don't. It heads through the solar system, as you can see. This one happens to be heading for our detector in Sudbury. It goes past our surface buildings, down into the mine, hits the center of our detector in this particular case, and gives us a burst of light. And that happened once in an hour only, even with $300 million of this stuff. That's still all that we could observe. There are very weakly interactions as a result of sunspot cycles. Statistics associated with the measurements of neutrinos, just a few per year sort of thing. There was a lot of speculation about whether there was any relationship, but superchemical Kennedy has done it best, and they have seen no significant oscillation of their total electron neutrino measurements as a result of sunspot cycles. Statistics associated with the measurements of neutrinos, just in the model, doesn't work for neutrinos. It may be because it appears there's a couple of some light mass neutrinos and also a very heavy mass neutrino, which is different from the other particles. I mean, really heavy, as heavy as you can imagine. And that breaks the symmetry. And there are models that are associated with that particular observation of the potential for a very heavy mass neutrino that we will never see because it's so heavy. And what you end up with is what's referred to as a seesaw model, where the light mass and the heavy mass are kind of balanced between them in such a way that you get that system with light mass and heavy mass. And the light mass is very light, as heavy mass is very heavy. That's why they call it seesaw. But that, I think, is probably knows. In transforming elements on geological timescales. But they're very difficult experiments to be very definitive because of all of the uncertainties and what has happened to the minerals that are being studied. It's usually isotopes of the minerals having been changed as a result of